Hey, good morning, everybody, and Happy New Year. So we're back for this semester two. Today's first lesson, we're going to talk about evidence of a chemical reaction. So it's going to be module 6.1. So this is going to match the assignment in the Skyward 6.1, evidence of a chemical reaction. All right. So after you have looked through this information, this is just going to be practice. All right. Practice and information. And when you are done with this, you have a Skyward assignment to do for your grade. Now, if you for your attendance, make sure that you do the warm-up question on the day that it is assigned. It'll be time-stamped, and that'll let me know that you've accessed the materials here in Google Classroom and on this web page, and you know what's due for today. All right. So we have evidence of a chemical reaction. All right. So how to know if a chemical reaction has happened? There are some changes you can see, like a change in color, change in temperature, change in smell, change in taste, formation of a precipitate, which is when you may put two liquids that have dissolved substances in them, and then after you mix them together, one of them will recombine into something that does not dissolve in water, and it'll turn into a solid and appear like it is raining as a solid into the bottom of the beaker. All right. So like with precipitation, you have gas that turns to liquid, but you can also have a precipitate in chemistry is when you mix two aqueous liquids together and something solid combines between the two mixtures, something new forms, and that thing is not dissolvable in water and it'll fall to the bottom. We also have production of a gas or production of heat, light, or sound. Now, when we're looking at these things here, now you might say, well, what about chocolate milk? I mix chocolate and milk together. It tastes different. It smells a little different, but that's more of a mixture because they still retain their same properties, and there's no recombination of atoms. They're not breaking bonds and forming new bonds. So that's important here. An important piece here is that whatever happens here, that there needs to be atoms need to rearrange or change partners. All right, so they have to rearrange or change partners as they to have a chemical reaction happen. So there is some additional reading here. So if you want to go through the reading, if there's two websites here. You can pick one of these to go ahead and read, and then there is a short video here from YouTube to visualize the different evidence of a chemical reaction. There's a little drawing here. So like color change, like bread dough baking, it changes from a white to brown. Smell, if I have rotting eggs, those will change in smell. They'll smell bad after a while. Wood burning, so when I burn wood, I create smoke with carbon dioxide and water vapor, and the rest of the wood will turn into ash, and that's a new compound. It's different from the wood from before. It has a new set of properties. It's like powdery and darker, and it's changed colors. So it can be you can get a white ash or some black specks in there. So it'll change colors. It won't be that wood color anymore. Gas created. Baking soda added to vinegar will create lots of bubbles. Now, this is not to be confused with boiling. So if I boiled water, it will create bubbles as well. But it's bubbling because I'm adding heat and it's changing phases. When it changes phases, it still is the same substance. So if I have liquid H2O and I boil it and turn it into water vapor or gaseous H2O, it's still H2O, liquid or gaseous. So the chemical formula has not changed. If I mix baking soda and vinegar, I'm going to get carbon dioxide bubbles. All right, it's going to recombine and make something different. It's not baking soda or vinegar anymore. I'm making carbon dioxide gas. The formula is different. Heat or light added. So if I see or created, sorry, heat or light created, not added. So if I'm not adding it, so if I create heat or light on its own, like through a firework or through like heat packs that you can break, and then the heat will be released from them, that's a sign of a chemical reaction as well. So fireworks are an excellent example of chemical reactions. All right, so let's take a look at some examples here. We're going to circle examples of chemical reactions here. So wood that's been chopped, It's still wood. That's not a chemical reaction, nor is clay rolled into a ball. If food spoils, we actually are forming new compounds. So like we mentioned the rotten egg before, or like a banana will change colors and smell different and taste different after it's spoiled. So that is a chemical reaction. Crushing a can is not. Burning wood, definitely a chemical reaction. Anytime we see fire, there's a chemical reaction going on. Same here for seeing fire, explosions, fireworks. Fried egg, this is going to be a different compound as well. So you might say, well, am I just heating it up? But think about this for a moment. Normally, when you heat something up, when you heat up a liquid, it's going to start boiling. But with an egg, if I heat up an egg, it's going to actually turn into a solid, which is weird because it's, as I heat something up, it should go from solid and then heat it up more, it turns into a liquid. Heat up a liquid, it turns into a gas. But here I'm going from liquid to solid. All right. And that's because the new compound is going to have a new set of properties. So that new fried egg is going to have properties that it is a solid at room temperature or a solid at higher temperatures than the raw egg was. The raw egg was a liquid at room temperature. The new substance is going to be a solid at room temperature. Mixed baking soda and vinegar. So we talked about that. So that's definitely creates lots of bubbles and CO2 gas. So we don't have baking soda and vinegar anymore. After we mix them, we have CO2 gas and other products. Rusted nail. That's definitely a chemical reaction. So we start off with something like iron or copper. So symbol for iron is Fe. And then we add oxygen in there, and it's going to make a new substance. Either we could get iron 2 oxide or iron 3 oxide here. I'm going to draw some iron 3 oxide. And this is going to be a new compound because before it was iron and oxygen, and now it's combined to make iron 3 oxide, or I can make iron 2 oxide. Broken glass is still glass. It's not a chemical reaction. Mentos dropped in soda will definitely create a new gas. And then paper that has been cut, that is not a chemical reaction either. All right, it's still paper. All right, so I hope that helps you with your assignment. Make sure you get your Skyward assignment done. Make sure you do your warm-up to help me with keeping track of attendance. So you want to, if you can help me by marking yourself present by doing your warm-up. All right, and that's it for lesson 6.1. Have a great day. I'll also post a video here for lesson 6.2.